In this webcast, we're going to solve a general plane motion of a rigid body using absolute motion analysis. So the problem says that this T slot is moving upward while this arm AB is rotating clockwise at a given instant of theta, angle theta, 50 degree, and the acceleration and velocity of this slot is given both upward 3 meter per second and also velocity 2 meter per second upward of this T slot. The problem asks us to find the angular velocity of this arm AB and angular acceleration of this arm AB. So before we start solving the problem, let's do brainstorming. This problem involves translation and rotation. The acceleration and velocity is given. We're looking for angular velocity and angular acceleration. So the first thought could be how we can connect the velocity and acceleration to angular velocity and angular acceleration. We need to find a relationship between rectilinear position coordinate and angular position coordinate so that we can begin from there. So how can we do it? We can use the geometry given. This is the arm length AB is always fixed and this is changing, so we can tell it a variable y, and we know this theta. If we take this triangle out, so we have y in this direction, theta here, and we know fixed arm length AB. This length here is always changing throughout the motion, but we don't have to worry about it because we can link this length AB with our interest variable y using the theta. How? If we take the definition of cos theta would be the ratio of y over the length AB, which is given here as a 300 millimeter. We can convert it into 0.3 meter. So now if we rewrite this equation, we will get this equation. It seems easy from here, as we can think if we just take first derivative and second derivative, we might get omega and alpha, omega from here with first derivative, alpha from here with second derivative, and velocity by first derivative and acceleration with second derivative, and we may solve the problem. But we need to also be careful about the sign. So if we take this point as our origin, this would be our x-axis and this would be our y-axis. And if we take this one positive direction, y positive direction, this would be our negative y direction. And so if this is our negative y direction, anytime we take 300 millimeter cos theta, we will get y which is in negative y direction. So what we can do is that we can take the direction of velocity and acceleration in positive y direction. So our velocity and acceleration which is given would be positive, but we can take this relationship putting a negative in front of it because our y location is in negative coordinate of the y-axis. So we will take the upward direction of y as a positive, and we can take the clockwise as a positive direction for omega. Once I have decided on my direction, now I can take the first derivative and second derivative. So the first derivative of the left hand side gives me y dot, which is dy over dt, and on the right side I left the constant as is, 0.3. For cos theta I got negative sine theta, and this is the theta is a function of y. We have to add another term which is d theta over dt. Now we can cancel out these negative signs, and we can take a second derivative, which will give us y double dot, which is a second derivative of y. 0.3 remains the same. We have to apply chain rule on these two, taking this one as the first term and this is second. So we will keep the first one untouched, and we will take the derivative of the second term. That gives me second derivative of theta. This means second derivative of theta. And plus, now we're gonna take the derivative of the sine theta, the first term. That gives us positive cos theta. And since theta again is a function of y, and we're taking derivative with respect to t, so we have to add another theta dot, and there was the previous theta dot available, so we will have theta dot. We can also write theta dot square. So now we know the first derivative of y is velocity. So if we rewrite this equation, and we have 0.3 as is, we have the sine theta as is, and theta dot, we know d theta over dt is the angular velocity, so we put that. So now from this equation, we know we're looking for the instant when theta is 50 degree, and we know the velocity is given, which is 2 meter per second. And since we assume y is positive on this direction and the acceleration and velocity is moving in this direction, so we'll keep it positive. So if we plug the value, 2.3 sine 50 and omega. So now we can find the omega. So the omega we found is 8.7 radian per second. You can check your answer. Since we have assumed that clockwise direction is positive, so omega 8.7 meaning is that omega direction of the omega is clockwise in this direction. Now we have to find the angular acceleration. We can rewrite this equation, and let's see. So in this equation, the y double dot is our acceleration, and theta double dot is angular acceleration, and theta multiplied by theta, which is theta square, and theta dot is omega, so we'll have omega square. So now if we rewrite this equation, we will get this form. In this form, we know the acceleration, which is 3 meter per second square. It is in positive y direction, so we'll just put 3. Theta is 50 degree. Angular acceleration, this is the value we're looking for, and omega is positive clockwise 8.7. So if we solve this, we will get acceleration as negative 50.45 radian per second squared. So we got acceleration as negative. So what that means? This means that the acceleration is opposite of the direction that we got. So our omega was positive in clockwise. Our negative acceleration is telling that this acceleration is in this opposite anti-clockwise direction. So we can write negative 50.45, or also we can write 50.45 in anti-clockwise direction. Both are right, radian per second square. So now we have solved the problem. This is our answer, angular acceleration, and we solved angular velocity. Now we have to talk about more on the sign, because that was the main problem that most of you had, and you were struggling with the sign. So let's see what else different sign we could use. So for example, if we again take that as our origin, this as a positive x, because we don't care, we don't have any motion on that, and let's keep it as a negative x on this side. Now here, let's see, we're taking the downward as our positive y, and negative on the upper side. So what will happen this time? Our AB cos theta, this angle will give us now positive y. So we will have y equals to 0.3 cos theta. Now watch, we don't have a negative sign here, it's positive now. But you see we had the acceleration of the slot here, and also the velocity of the slot was directed upward. Now since we're taking the downward direction as positive, now we have to assume that the given acceleration, which is 3 meter per second square, would be negative 3 meter per second square, since they're upward and we are assuming the downward as a positive. Same as for the velocity, we have to assume velocity 2 meter per second negative, since they're opposite direction of the direction we assumed as a positive. So if you plug the same value, if you take derivative of this equation, but when you plug the value of acceleration and velocity, if you plug negative 3 and negative 2, you will get the same answer and same direction of angular velocity and angular acceleration. So if you have more question about the signs, you can always comment below and ask me. I'll explain with more problem if needed. But till then, thank you for watching. See you in the next video.